Hello, good afternoon, everyone. My name is Sohith. I'm from Mechanical Engineering. Today, my topic is about event functions. Uh, these functions have been deceptive properties. They are symmetric about the y-axis. Mathematically, a function f of x is even if f of minus x is equals to f of x for all x in its domain. For instance, the function x is equals to x square uh, x square satisfy the property because uh, minus x whole square is equals to x square. You'll see this how this symmetric simplified transformation, integration and real world applications. uh, Symmetric and even function is symmetric about the y-axis. This means uh, for that any input value x, the function output is the same for both x and minus x. Next, properties of even functions. Let's dive into the properties of even functions. uh, these graphs are symmetric about the y-axis. If f of x is even, multiplying by any even power n maintains the symmetric. Adding or subtracting the two even functions result in another even function. Lastly, derivation of even function alternate. The first derivation is odd, the second derivation is even, so on, so on. And uh, 0, if an even function has a 0 at a specific point x, it will also have a 0 at minus x. Domain. The domain of an even function is usually symmetric about the original function. um, Original function. Next, we will discuss about the graph of even functions. um, Here I have a plotted example of an even function. The graph of f of x is equals to x square shows perfectly y symmetry. Similarly, f of x is equals to cos x. An even trigonometric function demonstrate uh, symmetric in periodic behavior. Notice how flipping the graph across the y-axis result in the same image. This is hallmark of an even function. So the graph will be very useful for the even functions and odd function, as y is equals to cos x. And the graph have many values like 2 pi, 3 pi, 0, minus pi, minus 2 pi, etc. So we will discuss about transformation of even functions. First, we have to discuss about the horizontal shift. Shifting an even function horizontally does not change its evenness. For example, f of x minus c will be still be even if f of x is even. Vertical stretching or compressing a even function vertically does not change its evenness. Reflection. Reflecting an even function across the x-axis still maintain its evenness. This result function would be minus f of x. Transformation preserves the even nature of these functions. Vertical shift like f of x plus c keeps the function even. F of x is equals to x square if g of x is equals to 2x stretches its vertical but keep the symmetric intent. We will discuss about the examples of even functions. uh, Polynomial functions. Functions where all exponents are even functions. For example, f of x is equals to x square plus 4, uh, and x square, x x power 4, etc. Next, trigonometric functions. Cosine cos x is an even function, and it also have example like cos x, sin x, etc. And lastly, absolute value functions. F of x is equals to mod x is an even function and f of y is equals to mod y is an even function because they are reflecting symmetrics. This example highlights the diverse application of an even function across mathematically and scientifically. Next, we will discuss about the evaluating of even function. First, we have to discuss about symmetric evaluating the function for a positive values x and then use the symmetric properties to determine the value of x and direct substitution. If the function is given as an equation, substitute the equation. For example, x is equals to minus 2. F of minus 2 is equals to uh, minus 2 power square plus 2 is equals to 4 plus 2 is equals to 6. Now calculate the f of x. So we will get different answers like if you substitute x is equals to 2, f of 2 is equals to 2 square plus 2 is equals to 4 plus 2 is equals to 0. This confirms that f of minus x is equals to f of x, verifies it's an even function. Next we will discuss about the differentiation even function. First, we have to discuss about the derivatives. The derivative of an even function is an odd function. Uh, um, f of x is equals to x square, f dash of x is equals to 2x, and even an odd function. Next, we have to discuss its proof. This can be proven using the chain rule, chain rule and the differentiation of the even function. Differentiation again, f double mod x is equals to 2, which is which is even. Uh, for example, f dash of x is equals to 2x is an odd, f double dash of x is equals to 2 which is even. This alternative, first derivative odd, second even, etc. And it also have the derivative of cos x is minus sine and odd function. Next we will discuss about integrating even functions. uh, Integrating even functions, symmetric even functions are symmetric about the y-axis. The symmetric can be simply integrated. Integration, the definite integral of an even function over a symmetric interval minus a comma a integral over the interval a comma a. uh, Applications, this property is used for various mathematical conditions like solving differentiation equations. For example, there are many integration of even function is simplified by symmetric. For uh, mod a minus a f of x dx, where f of x is an even function. Next we will discuss about the real world application for even functions. Real world applications, for example, signal processing. Even functions are used in signal processing to analyze and manipulate signals. This Fourier transformation of an even function is a real valued function. For example, in our real life, these even functions will be used for signal processing, and uh, and it will be used for physics, electrical field and forces after source, symmetric. And it is also used for engineering students for analyzing waveforms, etc. It also uses for economics, like cost profits curves are often modeled as even function. Their symmetry simplify analyzes and compute its domain. So when we come to conclusion, to summarize, even functions are a cornerstone of mathematics with their y-axis symmetric, unique properties and application. We explore their definitions, and uh, even functions also uses like graphs, transformations and the role in calculus, and saw their relevance in the real world. Uh, it is very important uh, for even functions in our real life. So this uses for many purposes like signal processing for engineering students, and to calculate the wave, to calculate uh, cost, etc. Even functions are very useful for humans. uh, so we explored their definitions, graphs, transformations, and their role in calculus, and saw their relevance in the real world. Thanks